Oh, so this is episode 11 of Prologue is Amazing. I'm going to talk about functional programming, logic programming, procedural programming, and combinations thereof. Okay, so, and what I like about each of them and some kind of possible solutions to dilemmas that occur because not all the languages are there, like everything isn't available in one language. You have to make compromises, like so so a common argument people make about an Prolog should just be a library in another language, and often that is done right. Or Prolog should be a constraint library in other languages. But I heard from Marcus Triska is, well, why? Why don't Prolog does its thing, right? Like it's logic programming or constraint programming. So why not have it? Oh, why not have it? Um, so Prolog can do procedural programming, right? In one context, Prolog can be interpreted as both procedural and logic programming. So that so as you do it, it's like it's doing. It can interpret it like you can have something. One of the logic variables is the output, right? Like you're doing assignment between, like you're doing a function call and an assignment. So you can interpret like Prolog is also a procedural programming language, but it's also a logic programming language. So there's also built-in backtracking or built-in search procedures, right? So why not, you know, rather than have a mostly procedural language and then do logic programming here and there, why not have it all available all the time? Now, some so there is a benefit to functional programming. It's that like there's a certain kind of simplicity over procedural. It's like where you're always calling a function with inputs and then you don't have to declare the output. It just comes. Now there is little syntax extensions in Prolog that allow you to get some kind of functional programming in there. Now that doesn't fully cover the case. Well, there's languages like Haskell and OCaml where they have also static typing over functional programming. So then what you have to think about is that, well, Prolog, even with this functional extension, won't let you do that, right? Like you don't have function, you can have function composition, but it's not typed. Well, there's a language called Mercury Prolog, which is developed at, I think, University of in Melbourne in Australia. It's a very small niche language, although the PDF viewer in the Google Chrome is created in it, right? So it has this niche, but it's like it's used everywhere. It's on every computer. The output of a Mercury Prolog is used on every computer because any computer that's doing using Chrome to do PDF viewing has that, or like either those professors there or company use that software to create it. Now, Mercury Prolog is kind of like amalgamation of Haskell and Prolog. So it adds to Prolog static analysis in the way Haskell does, and it also has like the way that Haskell is a pure language, or it has a it's it's a way, like in Haskell, there's a way to declare purity, and whenever you have side effects, you have to declare them. Mercury Prolog does that too, so it forces you to declare where your language is being pure. And then I don't really know it. I've never really used it. A long time ago, years ago, a decade ago, I did compile it, but I never used it. So, and I can't remember exactly what similarities and what the features are. Maybe it has laziness. I'm not sure, but it does have purity, and it has that Hindley-Milner type system, and but it has all the Prolog relational thinking. I don't know if it has like function composition, like a special syntax to do. It likely does, right? So yeah, these are all the languages that can combine. Yeah, so that's one way. Like there's a group of people that decided, well, Mercury Prolog will. They couldn't. They wanted Haskell features in Prolog, and so they went ahead and did it. I don't know enough about programming to know whether static types is important if you're doing relational programming. Because let's say in SQL, there is static typing. So you declare your tables and the columns of them, and they have to be the same. But in Prolog, they don't have to, and maybe that's an advantage. I'm not sure. So yeah, that's some thoughts on that subject. There was a language called Oz, and the author of that, Mozart Oz system decided to create this language called Alice ML, which basically is OCaml with the constraint programming library. Right, so you can see that it's like one group of people, they decided, well, Prolog is bad. Like how to make Prolog better is you use OCaml, you use an ML language and add a constraint library. And then there's the Mercury Prolog people, which decided, well, the way you make Prolog better is you keep Prolog and add static types. So those are two different approaches. In the wide sphere of programming, nothing has really caught on. Constraint programming, I think most often is done with something like Google OR tools, Google operations research tools, or other, software of that type, solvers. So that's the way most constraint programming, I think, actually is done in the real world, like how it's most often done. Now, Marcus Triska says, like I said earlier, why have a procedure or even a functional language and then use a constraint library? Stick to Prolog and you get all of that, and you can do your procedural or functional bits in little bits of Prolog. But of course, it won't have the static types. But, there's things, I don't know, I think there's workarounds in the Prolog ecosystem where it's like you can optionally declare types, and also things like assertions can help in doing that, like some kind of assertional programming. But that's not static types, right? That's just like kind of checking. That's dynamic type checking, basically. But the Marcus Triska says that it's like the real benefit of Prolog is that you can create meta interpreters. So basically, you can interpret very easily. You can start to extend the Prolog language itself. And I'm not sure if Mercury Prolog, because of its static typing, allows you to do that. So I don't know if you should go to Mercury Prologue because maybe it loses that, the ability to view the program as source code, the source code as data, and then start extending upon it, right, and interpreting the program differently. Uh, yeah, should look into Mercury Prologue to read whether that is possible or not. All these things are so unique that like they have such limited user bases that it's like there's not a lot of stuff written about it, and like it's not in the common parlance. You can search on YouTube and you'll hardly get anything. You'll get blog posts here and there, and maybe you have to read the user documentation. But even they might not describe it. You might have to read research papers by language authors to even start talking about that stuff. So anyway, for now, in the Prolog community, SDWI Prolog is the most commonly used Prolog, and so I think I'll stick to that. And for now, and yeah, so